Okay, can we start, sir?
Yeah, let's start.
Okay. So, hello all. Welcome to the IIT Gate classes. In this session, we are going to cover Gate 2024 Mechanical Question Paper Solution. So here we are going to discuss the section B, and the subject will be fluid mechanics and hydraulic machines. Now, coming to the subject weightage in the 2024 paper, so you can see the total 4 questions were asked, and the one question were of 1 marks, and the 3 questions were there of 2 marks. So totally we have 4 questions. Totally we have the 4 questions, and the weightage given for this subject was 7 marks, guys. Right? And this is the usual weightage for fluid mechanics and hydraulic machines. But the again, what the common pattern what we are observing from the past 2 years, they are not giving any question from hydraulic machines. This year also we don't have any question from hydraulic machinery, right? So coming to the question, guys, here we are going to see the question number 1. As you can see, the question is MCQ, and the question is from the fluid kinematics, guys. Fluid kinematics. Here, try to observe what they are giving. They have given the velocity field of a two-dimensional incompressible flow, which is as V is equal to 2 sine hx plus V of x of y j cap. That means the velocity field is given in the xy plane. The first thing what we are observing, the velocity field is given in the xy plane, right, guys? Where you have the u component of velocity and v component of velocity. If the v of x comma 0 is equal to cos hx, then what is the v of 0 comma minus 1? So before solving this question, first of all we should know the what is the meaning of incompressible flow, right? So 2D incompressible flow, 2D incompressible flow. What is the equation, guys? The equation for 2D incompressible flow will be dou u by dou x plus dou v by dou y, that is equal to 0. Because it is mentioned two-dimensional flow, so third component will be 0, that is w will be 0. The velocity vector w will be 0. And when you see the velocity field v cap, which is given as 2 sine hx plus v of xy j cap. Here u component of velocity is what? 2 sine hx, and the j component of velocity is what? V of x comma y. Try to put what is the dou u by dou x? Dou u by dou x will be 2 cos hx. And what is the dou v by dou y? It will remain dou v by dou y, right? Because we don't know, we need to find it out. So here I am trying to putting 2 cos hx. What is the dou v by dou y? Let's keep it like this. Now from here, what is the dou v by dou y? Minus 2 cos hx. Now what you do, you try to integrate it partially with respect to x, then what you can get, partially with respect to y, then what you can get, guys, you are going to get the v component. And whenever you are doing the partial integration, you are always put some function of other variable which is treated as constant over here, right? So here minus 2 sin hx plus sorry, here it will be, we are integrating with respect to y, so we have to treat x as a constant. This function will be constant, so minus 2 cos hx into y plus some function of x. In the problem what they have given, v of x comma 0, it is given as cos hx So put y is equal to 0. What you can get? Cos hx. Y is equal to 0. This will be 0 plus f of x. So finally, what is the v? Minus 2 cos hx y plus cos hx. Now we need to calculate at 0 comma minus 1. That means x will be 0, it will be 1, y will be minus 1 plus cos of h of 0. So again it will be 1. So 2 plus 1, which is equal to what? 3, guys. This would be the answer of v component of velocity of a two-dimensional incompressible flow. So the keyword is two-dimensional incompressible flow. This is a very, very important term, guys. Incompressible flow. The volumetric strain rate will be 0. What is the meaning of incompressible flow? Del dot V is 0. Note down here. Incompressible flow, del dot V will be 0. Del dot V should be equal to 0, guys. Incompressible flow. Right? So this is regarding the question number 1. Means the question number 16. Right? Which option should be correct? C should be correct. Moving on to the next question, guys. Here, please have a look for this question. Again, this is the question of MCQ. What they have mentioned, guys, here. They have given the pipe network. I will show the pipe network here. In this question, all the pipes are having the same cross section and can be assumed to have the same friction factor. Same friction factor. Here they are mentioning the same friction factor. The pipes connecting point W, N, and S with the joint J have equal length. The pipe connecting the point J and E has a length of 10 L. The pressure at the ends N, E, S are equal. The flow rate in the pipe connecting W and J is Q. Assuming the flow to be steady, incompressible, and the pressure losses at the pipe entrance and the junctions are negligible. Consider the following statement: the flow rate in the pipe connecting J and E is equal to Q by 21. The pressure difference between J and N is equal to the pressure difference between J and E. Which of the following option is correct? So let me show you the network here. This is the pipe network, guys. The cross sectional is same, that means diameter is same, area will remain same. The discharge is different, so velocity will be different. But head loss, sorry, here friction factor will remain same in all the pipes. The friction factor will remain same in all the pipes. So what we are doing here, we have the junction J, N, E, S, W. What I'm doing, I'm drawing once again. So here we have the junction, the discharge Q is given. This is the junction J, the common junction J. What they are mentioning, the pressure at a point N, pressure at a point E, pressure at a point S, all are equal. So from here, what we can get one thing, if I subtract J from all the pressure value, Pj minus Pn, Pj minus Pe, Pj minus Ps, there is no problem at all. There should not be any problem at all. After this, my dear friend, what we are doing here, When the pressure losses are same, that means when the pressure losses are same, that means delta P in the pipe N, delta P in the pipe E, delta P in the pipe S, all are same. When this delta P is same, head loss due to friction will also be same. That is also clear. That is also very much clear, guys. So from here, from the second line, you are going to get one thing, that the pressure difference between junction J and N and the pressure difference between junction J and E will remain same. In the statement, what they have mentioned, the pressure difference between the junction J and the pressure difference between the junction J and E equal. So statement 2 is correct. Let us focus on this statement number 1. What is the flow rate in the pipe connecting J and E? That means indirectly they are asking what is the flow rate over here. That means what is the QE? As they have mentioned Q by 21, whether it is correct or not, let us see. Let us see, guys. So when the head loss is same and the friction factor is same, right? Friction factor in N pipe, friction factor in E pipe, friction factor in S, all are same. Friction factor is same. So what we can get from here, guys? They have not mentioned anything like lambda or turbulent flow. So we are going to use the general formula, FLV square over 2GD. If I convert it in terms of discharge, I will be getting FL Q square over area. Area is what? Pi by 4 D square 2GD. So from here, head loss is what? Directly proportional to LQ square. LQ square. That is what you are observing. Again, when you are observing this thing, you can also observe that we can equate here this head loss due to friction, and what we can get, guys, head loss due to friction in the N pipe will be Ln Qn square Le Qe square Ls Qs square. And from the mass conservation, we know that incoming mass that must be equal to outgoing mass. So what is the mass which is happening from the pipe W? Q, that is equal to what? Qn plus Qe plus Qs. So from here, my different, what you can get, length of N is what? L into what? Qn square. Length of E is what? 10L Qe square. Length of S is what? Again L Qs square. So Q is equal to what? What is the Qn? Qn will be under root of 10 times Qe plus Qe. What are the Qs? Qs in terms of, again, what we are having, root 10 Qe. So what is the Q you are going to get? Qe 2 root 21, 2 root 10 plus 1. So what is the Qe, guys? Q by 2 root 10 plus 1. If you see, this must be the correct answer for this question. But if you see 2 root 10 plus 1, so approximately Q by 7.32. But what they have mentioned in the option, guys, they have mentioned in the option Q by 21, so it is incorrect. So statement 1 is incorrect, statement 2 is true. B should be correct. Actually, B should be correct, but in the GATE official paper, they have given C as a correct option. That you can challenge this question. Definitely, you are going to get the mark for this question. Now, why they have given the statement 1 is also correct. There again, we can also justify, but that justification is not at all correct, 100% correct. Let me show you why option 2 or why option 1 is correct. If you think option 1 is correct, so head loss in the pipe N, head loss in the pipe E, head loss in the pipe S is equal. And from here, my defend, if you assume the laminar flow, assuming the laminar flow, which is definitely not at all worthy because they have not mentioned, but still I'm assuming the laminar flow. If you assume the laminar flow, then head loss due to friction, we know that it is what, 32. It's a 32 mu VL over rho GT square. If you try to convert in terms of discharge, 32 mu Q over area pi by 4 d square into L. Now understand, guys. So from here, head loss is what? K times of, it's a Q times of L, right? Because remaining things are constant for all the pipes. Now, my dear friend, length is what? 10L. What is the QN? Length is L. QS length is L. So QN is what? 10 times of QE, and QS is what? 10 times of QE. So from here, my dear friend, what you can get, no, something you are going to get, that is nothing but, again from the discharge formula, Q is equal to what? QE plus QS plus QN, which is equal to Q is equal to what? QE plus 10 times of QE plus 10 times of QE. So you are going to get Q is equal to what? Q by 21. But this is incorrect. They forcefully saying that this is correct because assuming the laminar flow. That too, even though if they mention laminar flow, they should not mention friction factor remains constant. Because if the friction factor will remain constant in all the pipe, Fn, Fs and Fe, then 64 by Re, then what will happen, guys? The Reynolds number will remain same in all the pipe. The Reynolds number will remain same. For the laminar flow, the Reynolds number will remain same. If the Reynolds number will remain same, then the discharge will remain same. That is not possible. So definitely they should not mention this thing. Friction factor remain constant. If they mean, if they are, either they need to modify the question, they should have modified this question. Otherwise, they should have kept the option. This is as correct answer. Q by 7.32. So this question properly you can challenge. Definitely you are going to get the marks if you have kept B as correct option. Coming to the next question, guys, here. Study incompressible flow of air takes place through the adiabatic converging diverging nozzle as shown in the figure. For a particular value of the pressure difference across the nozzle, the stationary normal shock wave forms in a diverging portion of the nozzle. And if E and F denote the flow condition just upstream and the downstream of the normal shock, which of the following statement is or are true? So again, this is a very basic question from the normal shock, and that is being expected from this particular thing. First statement, if you read what they mention, the first, if you see the first statement, the static pressure at a point E is lower than the static pressure at a point F. Density at a point E is lower than the density at a point F. Mach number at a point E is lower than the Mach number at a point F. Specific entropy is at E is lower than the specific entropy at point F. So first of all, we should know little bit about the normal shock. So here my different shock waves. Shock waves basically represent the abrupt change in the fluid properties. You know, shock waves represent the abrupt change in the fluid properties such as pressure, temperature, density, etc. Right. So whenever the shock waves, normal shock happens, whenever the normal shock happens in a diverging portion for a Mach number more than 1, inlet supersonic flow, Let's suppose there is a normal shock is happening. The shock wave front forming perpendicular to the flow directions, that is called normal shock waves. Whenever there is a normal shock waves are happening, and they mention in the problem that at a point EF, let's see, this is the point E, this is the point F. After the normal shock, the point F is there. Before the normal shock, point E is there. Whenever the Mach number 1 is there, more than 1, supersonic flow will become subsonic flow. Because normal shocks are adiabatic. Suppose this is the adiabatic nozzle. Adiabatic, irreversible phenomena. It's a highly irreversible and adiabatic phenomena that definitely entropy will increase, right? When the Mach number will decrease, the flow will become subsonic. Definitely, velocity will decrease, pressure will increase. What happened with the Mach number, guys? Mach number will decrease. That is what happening. What about the temperature? Temperature will increase as it is gets compressed. It's a one of the compression wave. Temperature will increase, but as you see that it's adiabatic, so there is no role of irreversible in a steady flow energy equations. So we have He plus Ve square over 2, that is equal to Hf plus Vf square over 2, which is nothing but H naught E is equal to what? H naught F. So stagnation temperature will remain constant. T naught E is equal to T naught F. T naught will remain same. What about the density? Density will increase, pressure is increasing, entropy will increase. Entropy S will increase, guys. What about the stagnation pressure? Stagnation pressure will decrease. Stagnation pressure will decrease. So while looking at the option, which options are correct, guys? Static pressure at a point E, static pressure at a point E is lower than the static pressure at a point F. Yes, it is correct. Density at a point E is lower than the density at a point F. It is also correct. Specific entropy at a point E is lower. That is also correct. Mach number at a point E is lower than the, no, it is not correct, because after the normal shock, Mach number will be less than 1. Here Mach number is more than 1. So Mach number at a point E is definitely more than Mach number at a point F. So A, B, D is correct option for 40 question. Right. So this is the solution regarding the question number 40, guys. Moving on to this question, what they mentioned, guys. See that here they have mentioned the question from dimensional analysis and similar dynamic similarity. The liquid fills a horizontal capillary tube whose one end is dipped in a large pool of the liquid. Experiments show that the distance L traveled by the fluid meniscus inside the capillary in the time t is given by something like this, where gamma is the surface tension, r is the inner radius of the capillary, mu is the dynamic viscosity of the liquid. If the k is a dimensionless constant, then exponent A will be what? So here, guys, try to observe. So here directly we can solve by using what? By comparing the dimensions here. Here what they have given, L that is equal to K R to the power B. What is the dimension of a L? It's L only. K is a constant. What is the dimension of a surface tension? Surface tension is basically F by L. F is what? ML T minus 2 over L. What you can get, guys, from here? M MT minus 2. MT minus 2 to the power A. L to the power B. What is the viscosity? Viscosity will be ML minus 1 T minus 1. ML minus 1 T minus 1. And what is the time, guys? Time will be 1 upon 2. t to the power, sorry, 1 plus 1 upon 2. If you compare the dimensions of m, so it is a, left hand side it is 0, m to the power 0, t to the power 0. So what we can write, guys, here, t to the power 0. So here a plus 1, that is equal to 0. So a will be equal to minus 1. Just a moment. Sorry, a plus 1. Here we have to the power c, a plus c, that is equal to 0. That is equation number 1. If you compare the dimension of L, b plus b minus c, that is equal to 1. That is the second equation. And if you compare the dimension of a t, which is nothing but minus c plus half, that is equal to 0. C will be equal to half. But no, here minus 2a minus c, that is equal to 0, but plus half. So from here minus 2a, that means 2a plus c, that is equal to minus half, and a plus c is equal to 0. So if you just write, you are going to get a is equal to minus 1 upon 2 plus 1 upon 2. Here a plus c is equal to 0 minus 2a, that is a 2a plus 2c, that is equal to half. So it will be a is equal to plus half. Similarly, what is the c? C will be minus half. And what is the b? B will be equal to, what is the b value? 1 plus c, which is obviously again half. So what they are asking? They are asking r is inner radius, k is a dimensionless. Then what is the exponent a? What is the exponent a? Half. 0.5 is correct. 0.5 should be correct. So that is all about this fluid mechanics session, guys. If you have any other query, you can contact us, and for more information, for more further update regarding further batches of gate 2025, you know, you can just regularly visit our Telegram channel, right? Thank you all.